Hello, my name is Gonzalo Galotti and I work in the development team at GeneXus. And in today's session, we're going to be talking about the architectures of applications that are built nowadays in the cloud, which are modern, scalable applications. And we're going to talk about how we can build this kind of application using GeneXus 18. And if we talk about the development of applications nowadays, contrary to what you may think, nowadays it is much more complex to build applications. Well, the reason is that nowadays we have many more requirements than we have to meet. For example, it needs to be multi-experience, web, mobile, APIs, chatbots. You need to think about scalability and availability. You also have to take into account security, performance, observability. It needs to be integrated with other applications, and all of this needs to be agile, with innovation and at a low TCO, both in terms of operations and development. So we need to take all these requirements into account to build an application which becomes really sophisticated. But luckily, the cloud is a tool that allows us to nowadays solve many of these requirements in a much more straightforward way. Clearly, the cloud nowadays is the main catalyzer that is allowing us to build modern and scalable applications in a fast, straightforward way. And if we think about the cloud, I'm certain that the cloud is and will be the natural evolution of companies and the systems that we're building. If we talk about the cloud, or at least this path towards the cloud in our organizations, it's a long road that can be divided into several steps. As you can see on the screen, I divided it into 5 stages. Some may think that there are more, some may think that there are less, but what's important is that our organizations, companies, and systems are in at least one of these stages. Some trend towards the left, some others towards the right. So if we start at the left, we will find legacy monolithic applications that run in our infrastructure that are tied to software and hardware that depend on things that are installed in those servers and that are difficult to evolve because we don't have a DevOps pipeline that will allow that application to be future proof, and everything becomes a bit more complex. So, as we move to the right, which is where we want to be eventually, we're evolving and we're incorporating services from the cloud that will allow us to create better applications that are more scalable with a DevOps pipeline that is well defined and that will allow us to grow in scalability, focusing on the business functionalities and not so much on the infrastructure. So I think that this is a trend that has been around for quite a while. Companies have been migrating to the cloud for a long time. It doesn't mean that you need to be 100% cloud based, but sometimes you can choose a hybrid model. And is if an organization, if you want to be towards the right, you're talking about modern applications which are cloud native. And what does this mean? Well, on the screen you can see an example of a modern architecture for an application that is cloud native and that it's maintained and consolidated by a modern architecture. This is an example of a specific application which is it's a ticketing company, an online ticketing company that has an architecture that can scale up infinitely, which means that the application is prepared to support an audience of one person or millions of people simultaneously in a serverless way, uh, which is where we are trending towards. You can see some interesting components on the screen, such as, for example, an Angular application that is accessed by a CVN. You also have asynchronous communication using message queues between services and backend. You also have a connection to a DynamoDB table, which is a non-relational database that will allow you to it will allow you to store information, and all of this is run in a serverless platform without having to worry about scalability. Everything is automatic. So this is an example of one of the applications that we're building today in the market, in the industry, and the cloud. And the most important of this all is that this application that you can see on the screen was built with GeneXus 18. You can see here a QR code that will give you access to all the documentation of this application, this architecture. You can see some of the decisions that we made and why they were made, and of course you can have access to the KB and to the example in real production so that you can see it from the web. So the pillars of this GeneXus 18 version were to build modern, secure, and highly scalable applications in the cloud. So in this version, we focused on four pillars. We have technology updates, database scalability, service messaging, and last, serverless computing. So we work with serverless platforms throughout our applications. And if we think about what we did in terms of technology update, and we focus on some of the main aspects, we will have first of all the Java generator, which was updated to the last JDK update with the latest security updates, and even most importantly, that we implemented a new build system for GeneXus Java application based on Gradle that will consume packages, repository packages on Maven, which will allow you to work much faster, updating components in a much faster way, which you couldn't do before. For .NET, we also support the latest version released of .NET 6 by Microsoft, which for us is particularly important because it is the future bed of Microsoft to be able to run cross-platform applications both on Windows and Linux, and particularly in containers. And in the same way that in Java they created a new build system, in .NET we also have a new implementation of the compiling system for .NET that uses Nugget, and it will allow us to evolve that much faster than before. And as we talk about containers and cross-platform and the fact that applications need to be containerized so that they can run in any environment in an isolated way, it's important, I think, to highlight that in this version we put a lot of emphasis on the setup of those containers. All the adjustments that have historically been in client, FSG, or web config, they can be now modified via variables in the environment, which is particularly important because it's a step that we took in this 18th version on top of an API that allows us to programmatically make queries for those configurations. And why is this important? Because when we move towards containerization, which is so relevant in the cloud, we need to be able to create environments that will be both for testing environments and production environments without having to redo the container. The next point is database scalability. This for us is extremely important because reality shows that 90% or 99% of the times that an application has some performance issues or is having any kind of issue, normally that happens due to the scalability of that database. Why? Because scaling up a compute is extremely simple. It just means adding new nodes, and with that you will be scaling up. But scaling up a database is complex. As a matter of fact, today the only way that you can do that in GeneXus is with vertical scalability. That means by adding more CPU, more RAM to that database so that you can cater for higher demand scenarios. But that is not really good in terms of cost because you're maintaining infrastructure that will be not being used for most of the time. So we had to think about other alternatives or solutions. So in GeneXus 18, we took a big step towards non-relational databases, which are basically, they will give you more scalability. They will, for example, the case of DynamoDB, where you add support in this first stage, both for the Java and the .NET generators, and it will ensure infinite scalability, which means that regardless of the demand that you have, the database will be able to reply to any kind of demand, whether it's one person or a million people. You do need to plan that beforehand. And you're going to be paying for what you use, not for uptime, just because the database is on. And in the case of the architecture that I was showing you before, which is a reference case, we're using DynamoDB in a part of that architecture where we are storing in a table on DynamoDB the information of tickets so that users can check their information about tickets. Why DynamoDB? Because it gives you scalability. If you have one person or a million people having access at the same time, you're pretty certain that it's going to work nevertheless. But a non-relational database is not the solution to all problems. This has been proved in the market. Companies did not rule out relational databases to move to non-relational, but rather they incorporated it to overcome certain barriers. So relational databases will remain important for data access, and that's why we realized that we needed to take another step. So in this 18th version, we are introducing support for read replicas. What does that mean? A read replica allows us to, instead of having all our application have access to the primary database, you can distribute the load in different replicas. So these are different databases that are an identical copy of the main database. And in this way, you can distribute the load in different nodes, and you can scale horizontally, which is something that you couldn't do before. In GeneXus, the only thing that you will have to do is to define a new data store that we will have to specify that it's a replica. You will create a data selector, which you're going to tell that it should have access to a replica, and in the for each lines in any navigation you will be able to use that and specify to the code to GeneXus that this needs to do a read replica. So it will tell you that that is happening. You will know what's happening and you will understand the behavior. So these are some of the news in terms of the scalability of our database. I think that these are two important pieces of news. One is the support for non-relational databases, such as DynamoDB, and very soon we will be incorporating Azure and Cosmo DB, and probably MongoDB, depending on the requirements. And also this read replica thing that will be available for this year. The next point, when we think about a native environment, a cloud environment, is thinking about how these services communicate with each other. We are used to, in a traditional model, having services communicate with each other via HTTP, so these services are coupled, and the scalability that they have is given by the scalability of each of them. So if the server is down, my application will not work because it depends on the other one. So in a more cloud-native model, communication between services, whenever possible, is usually asynchronous. So you're reducing coupling, you have greater resilience because it is given by the infrastructure, and you have unlimited scalability. So in the 18th version, we have new APIs that will allow us to overcome this with asynchronous communication patterns, such as a simple queue API support and a service bus API. So this queue thing is not something new. Most of you may know something about that. What we did was to implement an API that is allowing us to work from GeneXus with this message queue. And as you can see on the screen, we can overcome scenarios where you need to decouple the producers on the left and the consumers on the right. Instead of connecting them with a synchronous mechanism such as an HTTP call or a service call, what we do is we connect them through message queues. And in this way, we have the communication in a very decoupled way between consumers and producers. For the architecture of reference, we have a message queue for communication between front-end services. So when a person registers for an event, that is the producer, and then you have the consumers, which are reading that message queue and processing that event registry so that they can send an email or send a confirmation of the data regarding that event. So again, we separated through a message queue what would be the publishers and the consumers. From the point of view of GeneXus, you have an API that is compatible with Amazon SQS and Azure, which can be installed directly from the GeneXus module. So this is a new pattern, a new way of solving the communication between cloud applications. Moving to the last pillar of GeneXus 18, we have serverless computing. And lately, this is no longer a trend, and as a matter of fact, companies and businesses are born with this model. This new serverless model was born as the natural evolution of infrastructure as a service and platforms as a service, whose main aim is for us to worry less and less about infrastructure, obtaining automatic scalability. If we think about a traditional model, in a traditional model, we would work with virtual machines and servers. We have to manage scalability in a manual way. You need to specify how many servers you want and at what time to cater for the demand. And the difference is that you're also paying for lazy time and active time. So you're paying for servers permanently. But in a serverless model, what you do is you just deploy code, you have no infrastructure, it gives you more agility because you can focus on the business, and you will only be paying for use. And scalability is unlimited and automatic depending on usage. So for GeneXus 18 specifically, we have two categories. You can deploy serverless HTTP APIs in this model, and you can also deploy just functions that will be triggered by events. For the first case, for APIs, what does it mean for us as developers in GeneXus? It means that we can deploy in this model things like API objects, any application based on services such as iOS or Android or Angular. And what does a serverless deployment consist of? Well, basically, it consists of two things. When GeneXus is deploying serverless, it is building, on the one hand, a definition that will be deployed in an API gateway. That file or that definition is a file generated by OpenAPI 3.0, which can be deployed in an API gateway, which is going to be what's going to give you the services. And then you have a code package that is deployed on a serverless platform such as Lambda that will trigger that code, run the logics involved to each function. So when you get a request, the first one that will get that request is an API gateway that is then redirected to those platforms of functions as code, and that reply goes back to the client. In GeneXus 18, we have support for Amazon using API gateway and Lambda, and then Azure with API management. So in the example that we saw today for the ticket purchase application, we saw that all the front end and all the services that are nourishing the Angular application were deployed in a serverless model, because that gives you absolute scalability regardless of the number of people that are consuming it. It's always going to be active, and you're just going to pay for what you're using. You won't be maintaining servers, you won't be having a cost for something that you're not using, and you can ensure that you can work with one person or a million people. And connected to the Dynamo database, it gives you infinite scalability. Then in serverless computing, you can deploy different GeneXus processes, basically functions that are specific to overcome certain problems. You can deploy them in the cloud, and these functions or procedures with GeneXus, instead of being installed in a web server or a machine in a scheduled way that is run every few minutes, you can connect to the cloud, to the infrastructure, so that they will be automatically triggered when there are certain events happening. So in this version, you can trigger those functions and these GeneXus procedures automatically in the cloud. Whenever something happens, for example, you have an event such as a message in a service bus or a message in the message queue, you can trigger this every 5, 10, 15 minutes or via HTTP. So these are the events that we are supporting for the time being. And the idea of this, as I was saying, is to change what we know about the traditional model, where we had to install the different procedures, and you have to check new data regularly all day. And instead of having a pull module, you can have a push model that will trigger automatically whenever you have new data. So in this version, we have support for Amazon Lambda and for Azure functions. If you take a look at the reference example, when a person registered in an event, we would add a message queue, and instead of having a process that is constantly monitoring the message queue to get new messages, what we had is we created a GeneXus procedure and we connected that to the serverless model so that it will be automatically triggered whenever you get a new message. In this way, you can have procedures and functions that will be used depending on the time. And from the programming point of view, this is very simple, because we only have to create a procedure with some specific signatures, and in that procedure we program whatever we need to do in that function. And to deploy that with the built-in tool in GeneXus to deploy, you can just get that package and deploy it automatically on the platforms. So we can nowadays, with GeneXus 18, build a native, scalable, modern application in the cloud with all these services, as I was telling you, API gateway or serverless services or non-relational databases such as DynamoDB, message queues, etc. And what's interesting is that we built this for Amazon, but we can also do that for Azure. So we don't have to change anything in terms of the programming, because all of that will be regardless of the platform. In the same way that you connect to the message queue of Amazon or with the Dynamo database, you can also connect to the Azure services and next Google services. So if I want to summarize this, and what are the functionalities of the cloud, we definitely have technology updates, database scalability, service messaging, and serverless computing. So those of you that are interested, download this version and try these new features. Thank you very much.